Me again, coming at you live from Jack's bedroom still. Actually, not live, but you know what I mean. So anyway, I'm going to start today by going over 6 scatter plots. So this is basically the homework review. And the first one was the page in the book that I copied that had 4, and then on the back you had number, I think it was 1 to 4, and then 8 on the back. And then the second one is going to be the 2 scatter plots. One had to do with the fat versus calories, and the other one was the theme parks. So I'm going to go through that procedure with you. So what you need to do right now is to make sure you have both of those worksheets out so that you can kind of go along with me and check yours. Now, what's going to be frustrating for you is when we're finding the trend line of a scatter plot, there isn't a right answer. You need to be in the ballpark. We're all going to maybe be slightly different, and I'll talk about that as I show you the homework and present the screen right now. So I'm going to do that. Sorry, my cord is in the way. I'm going to present my screen, and we'll look at first the page out of the book that I copied. The reason that I copied it was so that you wouldn't have to redo the scatter plots. You know, you don't want to write in the book, so you were able to just kind of draw that. So I'm just waiting here for this to get started. Alrighty. All right, so I'm, going to check the movie, but I'm pretty sure you should be seeing that page and you know which one I mean now. Okay. So basically with number 1, the first thing you would have done was to draw a trend line through the center of the data. This data is really tight. So your equation should be close to mine on this one. Okay. Now, once I drew the trend line in, I go up my trend line looking for the 2 closest points that are in the crosshair so that I can name them easily. So they don't have to be data points, but they need to be as close to on your line as possible. So I'm going to pick the year 92 and 55. So in 1992, there were 55 million subscribers to cable TV, basically. But anyway, so there's one of my points. And the other one that I ringed is up here, and that is 9765. Now, you might have used 2 different points. Your trend line could be different, and that's okay. You should still be close to the answer at the end. Okay. Now notice some things that kind of help you see what I'm doing. I put a ring on the points I'm using, and notice I wrote the coordinates, which I absolutely have to see what you're doing. Okay. So now what I'm going to do is I'm going to calculate the rate of change, the slope between these 2 points, and that's what I'm doing right here. And my slope comes out to be 2. Now look at your slope. Are you close to 2? You shouldn't have 5. You shouldn't have -3, right? So you should be in that ballpark. Maybe it's 1.9, maybe it's 2.2, but are you in the ballpark of a slope of 2? Or are you possibly right on? Now, once I have that slope, I'm going to take the slope in one of my points. I picked this one, and I put it in the point slope. I do the distributive property. I add the 55. And here's my equation of the line. Now, what I do need to mention, I was trying to have this all on one paper to make it easy. Please note that I define my variables over here sideways. So when you write an equation, you should always tell me what does X stand for, what does Y stand for, and it's really easy off the graph because it's your X and Y labels. All right, so let's take a look at this. Now, your Y-intercept should be somewhere close to -129. You shouldn't have -250 or positive 300 or something, but you should be in that ballpark, basically. Now, what I want you to notice is that in this case, I had to use the point slope because look at the break in the graph on the X, and there's a break in the graph on the Y. Notice that my line is not coming anywhere near -129. This is not the Y-intercept of this line. Because of this break, this accordion and pulls out, way out. So you cannot trust the Y-intercept. If there's a break in the X, you can't use it at all. And if there's a break in the Y, notice how I'm hitting the break anyway. So I had to use the point slope here. I couldn't just say, oh, well, it looks like the Y-intercept is, let's see, what are they going by? 2.5. Oh, it looks like it's, 47.5. You can't do that, okay, in this case. All right, let's take a look at the next one. Now, the next one, I would expect you would be a little bit maybe more off from me because the scatter plot is more scattered. So its correlation coefficient, I mean, this one is close to a 1. This correlation coefficient would probably be like a 0.99 or something like that, if you remember that video. Over here, we're starting to spread a little bit. So, this one might be more like a 0.92 or something like that. So we could be further off from each other. And I'm going to talk about something else about these 2 points in a second. So I drew in my trend line and I ringed my 2 points. I wrote down their coordinates, and now I'm going to calculate the slope, and it's going to be kind of over here. Okay, sorry about the shadow. In Jack's room, there's a light directly above here. So y minus y over x minus x, 100 divided by 5. My slope is 20. And again, you should be close to it. But this one, you could have been like dead on. And this one, you might be slightly more off because of the scatter of the points. I'm going to take y minus the y equals the slope times x minus the x, distributive property. And this is my equation. And again, remember, I'm defining my variables. I'm using the longevity in years. And y is the gestation. Gestation, by the way, is how long a mom holds the baby in utero before giving birth. So for a human, it's 40 weeks. It's about 9 months, right? All right. So anyway, got off the topic there. Notice that my y-intercept is +0, which means my line would go through the origin. And notice that the line doesn't. And you're like, hey, what's going on? To be perfectly honest, when your 2 points are really close together, there's a little bit more wiggle room. The further apart, if you can pick them further apart, it will stabilize a little bit more. But this, could have a little bit more of a wiggle room. And that's why you can see my line kind of isn't going through that. Alrighty, so that was number 2. And again, you're not expecting that if you have y equals 19x plus 10, and all your math looks good and you have the right points. I mean, there's chance are you're not going to have this answer exactly, but I expect you to be close, and that can be frustrating. All right, number 3, again, look at the scatter here. This is going to be our worst one for you and me. I just noticed my arrows aren't there. For you and me to be on. This is a bad correlation. Even though it is a positive, it's a weak one. So like you might have drawn the line more up here, tilted a little bit. I mean, there's, it's hard to get that line. It's really hard to miss on this one. And it's really hard to get it sort of right on this one, to be honest. Okay. So I am going to draw my line. I picked the point. Let's see, that one's in the crosshairs and that one's in the crosshairs. Here are my 2 points. I'm going to calculate my slope, and it's about a 0.71, 0.7-ish, and point slope, distributor property, and my final line, y equals 0.71x minus 33.41. And this one, like I said, I would expect you to not be close. If you are, yay. And I know that I also checked these ones in technology, so I am close to the real deal here doing the statistical analysis, but if you're off on this one, we get it. To be honest, if I was doing an assessment, I am not giving you this one. I would give you something like this one or this one, to be honest, okay? But, in life doesn't always give you those. All right, last one, number 4. Again, my points are kind of close here. You'll notice that, just finding them in the crosshairs. I used 1.580 and 270. I did my slope, which comes out to be a -20 point slope, and there is the equation of my line. So my slope was -20. My y-intercept, if I extended this, would hit at about 110. And please don't forget, I am defining my variables. I'm just doing it sideways, trying to get everything on one page now. So those are those first 4. I'm just trying to make sure they're all here so you can take a look again at those. They're boxed. And we're going to go on to 2 more. Well, first I got to do the one on the back. So the one on the back, you had to do the whole shebang. So let's see that one. Number 8. So the first thing you had to do is make the scatter plot. So the things I want you to check is, do you have a title and your labels? The years after 1900 should be your label here, and sales, billions of dollars. We started with 1980. You really don't, I mean, some of you might have picked a different year. You might have said, well, I'm going to go after 1970 or something like that. And that's okay as long as everything works. But you could look a little bit different. Just realize that. And I would be studying everything you've done. That's why you got to defend your answers by showing me what you're doing. Okay. The next thing you did was once you set that up, you would need to plot the points. And there should be 1, 2, 3, 4, 5, 6, 7, 8 points that are plotted there. You'll see them on mine. You absolutely should have had dollars on your Y in the year after whatever you chose to do down here. You wouldn't start at, you'll notice when I went to do it, I'm calling it after 1900, so I can call it 80, 82, 84. That makes it a lot easier, especially when we go to the calculator. But I do have a break in the graph because there's no sense in starting at 1900. I'd have all my points would be way over to the right. So there is a break in the graph, which means this is not the y-intercept since there's a break in the x. So I am going to have to use point slope form. I'm going to put that there as well. Okay, so I have all my points. I draw my trend line. This should be tight. This is a pretty good correlation coefficient. Again, I'd be thinking of 0.98, 0.99 on this one. And now I go up my trend line and I go all the way up and kind of do it a second time to find the two that are really the best. And the two for mine would be 90, 180, and 98, 260. So I'm pulling off those coordinates of those 2 points. And now I'm going to calculate slope. My slope comes out to be 10. I decided to use this point slope form. And here is the equation for my line. Okay, so you should be in that ballpark. Now, if you mine is like that because I said after 1900, that's why there's an 80. If you did after, if you're putting like 1980, 1982, things are going to look different down here. I would recommend in the future, if you did do that, to go to just showing kind of the 2 years. By the way, if we got to year 2000, it would be 100 years after 1900. It's going to make your life, when we go to the graphing calculator, a lot easier. I did put this one in the graphing calculator, just so you know. And here is what the official answer is. So they do the statistical analysis, and it came out to be y equals 10.6x minus 772.66. I'm pretty darn proud of myself because look how close I am. And hopefully you're somewhere in there as well. It was a correlation coefficient of 0.99. Remember, that's what the R is. And that tells you how tightly it is connected to the perfectly sloped line, which would have been 1. So I'm going to, again, just kind of leave this for a second. And I will pull it down again just so we can see it. And that one is the real deal, start to finish. And we're going to go over and do 2 more, which would be the fat versus calories and the attendance at the theme parks. That's coming next. Okay. Post it on Classroom. All of the answer keys will be in case Rowan just asked that question. Kidding, Rowan. All right, here was the fat and calories. And we're trying to see, is there a connection between the calories in something and the amount of fat grams? My guess off the top would be, oh yeah, but we're going to prove that. All right, so when you went to make your scatter plot title, and the calories depend on the fat, so fat should be your X and calories should be your Y. It really should be that way, not the reverse. The calories change based on how much fat is in an item, not the other way around. So I plot, in this case, the 7 points. You'll see them as the dots over here. And then I drew my trend line in. Oh, sorry, I forgot about the label. So I'm doing, to spread it out a little bit, because I got to get up to 40. So I wanted to kind of spread the data and not have it all sitting in here. So I'm doing basically 2 blocks for 5. On the way up, I noticed that the smallest was 220. So I have a break in the graph. My y-intercept is not going to be good because this line hits, below it. And I'm going up 50. And again, that's to, number one, spread the data so you don't have this tiny little graph, and also to center it so it's not like sitting up here. Okay, so that's, now I plot the points. Now I'm on track. I plot the points. I draw in In this case, my ray, it does not make sense to have an arrow down here. Wait a minute, did I just lie to you? No, because you're not going to go below 0 fat. So since this is 0 fat, it's going to end sort of somewhere there. Alrighty, plotted the points. Next thing, I write up my line and I find 2 points that are in the crosshairs and I write the coordinates down. There they are. I'm going to calculate my slope and use the point slope. I chose the point without the decimal. Of course I did. Distributive property, add the 500, and here is the equation of my line. Sorry, I just looked a little, and don't forget to find your variables. Okay, so having said that, are you close? And now what I'm going to do is show you, I put this one in the calculator as well. We're going to learn that. After we take the test, we're going to actually go back and use some technology. Talk more about that in the future. And you will be able to do what I'm going to do right now. So I'm going to give you the actual, the real deal, the best equation using the calculator, graphing calculator. And notice it is y equals 3.56x plus 150.87. Not so shabby. I'm feeling pretty good. See what I mean? I'm not exactly on, but I'm feeling pretty close. Okay, you ready to talk about the last one? All right, flip it for the theme parks. So, is there a change, a correlation between attendance as time goes by, basically, on this one? Okay, your title. The year, again, being time, we usually talk about change over time, which would make this the X. So that's kind of what you're going to see down here. And again, I'm not putting 1995, 1996, 1997. I'm going to define my X as the years after 1900. Get used to doing that kind of thing for calculator and technology purposes. It makes it easier. Okay, and I'm just showing you this is going to be, that 1900 is on the left-hand side of this break. So again, we cannot trust this y-intercept because of this break right here. This would accordion and pull out. So my y-intercept is not going to be like 280, and you'll see that in a second. Once I set up, I did a year going this way, and going up, it's, 5 million per block, basically. Plot my points, find 2 in the crosshairs. One of them is actually a data point this time. Well, no, I lied. It's a little bit above. That's actually 19. See the 2001, 319. I'm actually going to use the 2001, 320 is what I'm using. And then up here would be 103, which is 2003, and 330 right there. So here are my 2 points that I picked in the crosshairs. I calculate the slope. It's about 5. I'm going to use the point slope. And when I calculate it, look at the y-intercept. See, it's not 280. It's like literally negative 203. That's because this would pull out. We're missing 94 years here. So this line would keep going down, 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 down. All righty. Are we okay on that one? How about if I show you what the calculator would do, and let's see if Mrs. Woodruff feels good about herself or not on this one. All right, so when I put in the data in the calculator, which you'll be doing in a couple weeks, y equals 5.4x minus 229. My slope is only 0.4 off from the real deal. Y-intercept, not so bad. So that's the process. You set up a good graph, title, labels, good scales, plot your points, draw in your trend line. Find 2 points in the crosshairs that are on the trend line. They might not be data points. List those 2 points, calculate your slope. Use the point slope will always work. You'll see most of these that we've done today, just slamming in y equals mx plus b with the y-intercept doesn't work. Sorry, my phone's ringing and I'm going to hang up on the people. Sorry. So the y-intercept only works if there's not this x break and if the line hits above. And use your point slope, calculate it, and there you have it. What is this useful for? Predictions. So if we wanted to go out now and say, what is going to happen if this trend continues at the theme parks? what would happen in 2020. And if it weren't a pandemic year, we could make a prediction on what the attendance would be. So in putting in that X, we would put 120, and that should have been the attendance, say last year. Of course, we know that this trend did not continue. Things changed. All right, so that is just a good handle on how to do a trend line. I'm going to have you do a little bit of practice, and I will go over that practice at the end. So let me go back and say hi. Stop presenting. So give it a practice. You're going to do a scatter plot yourself. You're going to fill one in, and then you're going to do just some other review problems with rate of change and see some problems of how these questions would be asked, like on a standardized test. I've got a few of those as well. So have a great day. I will talk to you soon, and I got to stop recording, which always is this time lag. And I hope you have a great day, guys.